Probably. Yeah, that's okay. So let's move on here. So what we were doing was we were looking at a set of data, and we wanted to create both a frequency distribution and a histogram. So the frequency distribution is just a number, is a table with numbers in it, and at the end of the period we were constructing, we were going through each piece of data and we were determining which one of the classes it fit into. So I went ahead and finished that. I forgot to do it yesterday, but I did it this morning. And so there were 3 numbers between 100 and 104, 8 numbers between 105 and 109, and how many is that? 16 in this class, 13 in the next class, 7 in the next class, 2 in the 125 to 129, and 1 in 130 to 134. So that is the way you manually figure out the numbers in each class. And then so what we would do is the frequency distribution would look something like, let's see, 1, 2, 3, 4, I need 8 rows, and I'm going to do 3 columns, and I'm going to put this on the next page. So all I'm going to do is make a new table and have some numbers in there instead. So the numbers in the frequency distribution table consist of these ranges again. So I'm going to say 100 to 104, 105 to 109, and I'll just copy them down. Oh, and the reason I made one row longer because I was going to put a header in there, which I forgot to do, so let me do that, sorry. You can write something up at the top. So this is, we'll call this the class, and this we'll call the frequency. And this is what we're going to call relative frequency. Okay, so the class is from 100 to 101 again. Fill out them now. And remember, the requirements for the classes are that they are the same width, which they are. They're all 5 units width. There's no overlap, and because the input data was a integer, it's easy to do. Now, if it was a decimal, you'd have to decide, where am I going to end it? Because I might end it at 129.9999999, and then the next one would be 130.0000. So it might look like there's a gap because you're going from 129 to 130, and there's space in between there. But because all the data were integers, it's not going to fall through the cracks. And you wouldn't want to use the same number here because you would have overlap at 130. So somehow you'd have to specify it so that it would mean from 125 to any number less than 130. And then you go from 130 to any number less between 130 and 135. So it's those intermediate things you got to be careful about. So they're the same width. They are, we have 7 classes. We said that we'd like to have between 5 and 12, so that works out good. And then to fill out the next column, all we do is just count the tick marks over here. So we have 3, 8, 16, 13, 7, 2, and 1. Now, what the relative frequency is more like a percentage. What percentage of numbers are in a class? So the way you calculate relative frequency is you would add all these numbers together. So let's see what we get. 11, 27, 37, 40. There's 50 numbers. So if you add, so I'm going to use this summation sign to show that I'm adding all these things together. So there are 50 total measurements. So the relative frequency is going to be the number, the frequency for a given class divided by the total number. So you can show it as a let me put this on one page so you can see it better. You can show it as a fraction, or you can show it as a decimal. And the decimal here would be, well, I might use my calculator, but I think it's 0.06. But because you're dividing by 50, you can take that top number, multiply by 2, and then just adjust the decimal point. So it's 0.06. And this one would be 8 divided by 50, which would be 0.16. So I'm doubling it, 8, I'm getting 16. 16 over 50. So you double that, you get 32, so that'd be 0.32. 13 over 50, which would be 13 times 2 is 26, so it'd be 0.26. Then you get 7 over 50, which would be 0.14. 2 divided by 50 would be 0.04, and 1 divided by 50, which would be 0.02. And if you add all those numbers together, the relative frequency, then you would get 1. So 22, 52, 54, 74, 80, 90, 94, 98, 100. So yeah, they do add up to be 1. So there's two ways of looking at it: relative frequency and so you can almost think of relative frequency as being kind of like a probability, in that if you had all that data, all those 50 data points, and you put them in a hat on a piece of paper, and you randomly picked out a number, these would be the probabilities that you would pick one of those. That's why you do relative frequency, because it's more like a probability distribution instead of what we call a frequency distribution. Okay, so that is what do we use the word terminology here? Those are frequency distributions. Now, a histogram is just taking that data and making a table or a graph out of it. So I'm going to do a sketch of one, and then we're going to show you how to do all this using spreadsheets. So we're going to do frequency on the y-axis, and we're going to just put in some rough marks. So this would be 5, 10, 15, 20. And I chose those because the maximum I have is 16. So, and then you would go down here and you would say, you would write in some kind of scale, 101 to 104, 105 to 109. I guess I should put it down there, my little minus mark. And then you have 110 to 114, 115 to 119, 120 to 124, 125 to 129, and 130 to 134. So those are my different classes, and then you would draw vertical bars to represent the number, the frequency. So this needs to be 3 units high. The next one would be 8 units high, which would be about right there. The next one would be 16, so that goes up to about there. The next one is 13, so that goes to about there. What I'm doing is looking over here and finding out the height to approximate these things. The next one is 7, so I draw a thing about 7 units high. and then 2 units high and 1 unit high. And if I had a piece of graph paper, I could do this more accurately. So this is what's called a histogram. And you can do it using frequency, or you could do it using relative frequency. The only thing that changes is just the scale. The the relative size of the different rectangles is going to be the same no matter which way you do it. And you probably have I don't know what the data stands for. So if I knew what it meant, I could put some kind of labeling on the x-axis to know what those classes represent. So what this allows you to do is basically give you an idea of, where's the middle of the data, because the middle of the data is going to be somewhere right in here, because that's the one with the highest frequency. So when I get to averages, means, medians, and modes, this will give me a good idea of what the mean is. The mean is usually the value in the middle, or it's just the average. So the average is probably going to be somewhere around, I'm guessing, 114 maybe. And I put it on this side because it's weighted a little bit heavier to the right side than the left side. And it gives you an idea of how much spread you have in the data by how wide this thing is. So it's just a nice visual way of looking at data. Now, you probably did stem and leaf plots in high school at some point, but my experience is that you don't really see that in the real world. People don't use stem and leaf plots. They use frequency distributions. They use relative frequency plot. They use frequency distributions. They do histograms, but stem and leaf plots, I'm not going to cover. You've probably seen it before. And another way to look at data is using bar graphs, pie charts. And I'll probably talk about this later, but right now we're just going to concentrate on the histogram. And I'm going to assign the homework for today, but I'm going to go back and cover a little more information relative to this whole idea of frequency distributions. So this will be due next Thursday. I have not looked at the tests yet. I had to finish grading my calculus test. So hopefully I'll get those back maybe by next Tuesday, definitely by next Thursday. Okay, so I think that's enough time. So, so these problems basically are, most of them are for creating this kind of data, this information. So I'm going to just demonstrate to you how you do this using a computer, and just some examples of other distributions just so you can see what they look like. And you'll have to do this in your project. But don't worry, if I go too fast, you'll have an opportunity. This is just to kind of more give you a general concept of how you might do this in the real world if you were actually doing this kind of analysis. So I found this data set, and what they did is they measured various properties of 200 or so males between, I'm not sure between what ages. And so it's a spreadsheet of the data, and we can do histograms for every one of these data points. This one is just their identification number, whatever they're not their name, but their number associated with that person. And then you've got percent body fat, you've got, I don't know what density, and I guess that's just like, is that what you've got age, weight, height, and all these other measurements. Start to measure stuff, chest size, neck size, and I guess they're probably in I don't think they're in inches, they're probably in centimeters. So what I thought might be interesting is I'm just going to take a few pieces of data here, and instead of trying to do everything, and I really don't need the number here, but I'm going to use it anyway. So let's see how many people. 252 people. Okay, so I'm going to create a new spreadsheet just so that I have less data. First thing I was going to do was look at the age, even though that has nothing to do with body. Well, I guess it could have something to do with body fat. So I'm just copying the data over, and let's just make this bigger. So it's just like, you know, if I go back quickly to the previous example, it's just a list of numbers. In this case, they're actually listed in numerical order, but that's, well, not exactly numerical order. So if you wanted to do a frequency distribution of this particular data, what we have to do is you have to figure out how wide the data, you know, what's the smallest value and which is the largest value. So let's typically, there's actually functions to do that, but we're just going to visually look at it. So it looks like, you know, early 20s, and if we just quickly zoom down here, I'm seeing what I'm looking for now is anything that's less than 20, and also just to see if there's any really old people in there. So I thought I saw an 80 in there. I'm just visually looking through here, and you know, these are in, so 74. Did we see anything any older than 74 in there? '72. Okay, so I'm going to write this on the board. So it looks like early 20s to about 75. That's just the rough sense of what the range of numbers are. So now I need to decide how I'm going to group the data. And again, I'm going to, if I did it every 10 years, I would have, you know, 10 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79. So that's how many classes? 6 classes. If I did it every 5 years, how many classes would it be? It would be 12. So so we could probably either choose 5, a class size of 10 or of 5. We might just do both of them just to see, you know, how it affects the graph, what it looks like. So the way you do that is I just type in class, and the way it works is it takes the number, let's say 25, and I'm going to go by increments of 5. So the next number is 30, and in spreadsheets, typically if you do 2 numbers sequentially, and then you highlight the 2 cells and you grab the bottom and you drag this down, it will automatically figure out that you're wanting to go by increments of 5. So you don't have to manually enter the increment. And you might say, well, don't you have to put like 20 to 29? But what it's actually going to do is it's going to give me everything between 25 and 0. But because I have nobody less than 20, it's still going to be 5. It's essentially going to be from 20 to 25 because there's nothing down to 0. And then this one's going to look at this number and go from this number down to that number. So the sequential numbers define the classes. You don't have to actually write in the, you don't have to write 25 to 30 or something like that. And typically this is Excel. This is, you know, it's not a brand spanking new version, but each version has the same kinds of things. They usually have things called add-ins, and one of the add-ins is a data analysis package. Now the one from Google Docs, they have a similar kind of thing. So the way you do this is you pick data analysis, and then there are all these different things that we're not going to learn all of them. There's one that says histogram, which is what I want. So then they give you a dialog box to help you fill in where the data is that you want to analyze. So the first one says input range. So the input range is my data. So all I'm going to do is just drag and highlight my data. And I didn't quite get it far enough. So you can also enter it manually. So there, I've got them all now. So those are that's the data. The second thing is to put in the classes. Well, they call them bins in Excel. So I click on the corner and I go to back to the top. Why isn't it going to the top? Oh, it's because I got to drag this thing. So the classes are like that. Those are my, they call them bins. And then with that, all you have to do is you can put the output range. What that does is that tells you where the frequency distribution, the numbers actually go to. So I'm going to click that, and I'm going to put the data right here, starting so that they're just to the right of the class numbers. And I'm also going to do a chart output. So it's going to do a graph for me automatically. And that's it. And I say OK. And it didn't like that. Output range missing. Okay, I thought I did. Oh, okay. Output range. There we go. So what this actually didn't quite align, but it does have the heading. So what this is saying is that there are 14 people that are 25 or less. There are 24 people that are between 26 and 30. There are 25 people that are between 31 and 35, and so forth. So it does that all automatically for you. You don't have to go through and check these things off and make it tick marks. It's something that's well suited for computers. So that's my frequency distribution. And I could actually go back and be more explicit about what these represent. I could say 20 to 25, 26 to 30, which I might do at some point, but that's not how it's actually presented. And then it automatically does this graph. And what I'm going to do is I'm going to move this graph to another page. So I got to remember where that is. Oh, here we go. Yep. So you can have it with your data, or you can put it on a separate page. So there's my histogram. So instead of having to deal with all that data, it automatically fits them into the correct bins. And apparently there's one person who's more than 80 years old, which I didn't catch in my looking through the data. So that's kind of how it works. Yeah, well, let's look through the data. Well, one way you could do this, one thing you can also do with spreadsheets is you can sort the data according to size. So what I'm going to do is I'm going to sort the data by column B, which is age. And so then I can look through. It's easy to look through then. The youngest person's 22. And the oldest person is 81, which I apparently missed when I was looking through there, but it goes, so you can see all the data. Well, there's not many people that are that age or who want to participate in the study. Let's just verify that these numbers that they have put here are correct. So it says there are 14 people that are 25 or less. So let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And now we go to the next stage. So that does verify that this is correct. So what I'm actually going to do is I'm going to go in here and change these to more like this. So they're actually more accurate representations of what's going on. And so you can just edit these things and put in whoops, I don't have them there. Okay, now if we go back to our graph, you'll see that now down here, instead of just having, it's pretty small. Let me zoom in a little bit so you can see what they look like. So now the graph would show the actual ranges of data. So if somebody saw this graph, it would make more sense to them. They'd know what those mean. So these are the frequency values. On the y-axis, the bars are as high as the number of occurrences. And the last thing that you probably would do in a graph like this is you would change the axis title so that you know what it stands for. So for example, this would stand for age, so that somebody's looking at the graph, they know what the heck's going on. And you can also change the size of the font. So, it's pretty small, so I'm going to make this 14. And we're going to zoom out. Anyway. Now I'm just going to show you how this works in Google Docs. Same set of data. So let me get to this. So what we're going to do is I'm going to share this with you. And so let me just show you how to do this. And again, it'll be on a video recording, but the more times you see it, the easier it is when you actually have to do it. So you log into Blackboard, and you go to Gmail, and at that point you can access all the tools and your files, which you may or how many people have used Google Docs for this in your classes at all? Okay, so there's the Sheets button. So that brings up Google Sheets, which is like Excel. And so to create a new file, you push the plus button. And you end up with something that looks like that. So it's similar format. If we go back to Excel, you see it's made up of boxes. You can zoom in a little bit here. How do you zoom in? Yeah, I think you have to just zoom in your screen. So let's Control plus. Yeah, there we go. So now it doesn't have quite as many options as does Excel, but it's not a bad spreadsheet. So I'm going to copy the data from here that I used earlier. For your project, I will provide you with a data file that you'll use. So there it is. Now the data is in this spreadsheet. Now there are add-ons, just like in Excel, there was a additional thing you can add on, and I'll show you how to use this. It's called Excel Minor Data Analysis Toolpack. So the other thing was called Data Analysis Toolpack. So it has a slightly different interface, but not crazily different. So again, you can choose the analysis that you want to use, and these are all statistical analysis. The only ones that we're going to use are histogram and let's see, where is it? Descriptive statistics. But if you took inferential statistics, there are all these different statistical analysis things that you would use. So we're going to use histogram. And the dialog box, somewhat similar. You do the input range. So the way you do it is you click in there, and then you come over here and you highlight. Well, actually, I think you highlight it and then you click into the thing. So let's see what happens. So my data is my age stuff. So you just highlight all the ages. So you click on that. There we go. So apparently you click on the, and let me copy over the bins too. So I'm going to copy over that information. So put that in my spreadsheet. I'll put it right here. So that's my bin information. So you highlight the bin information, click into the box, and then it does it. The output is going to be, we're going to put it up here somewhere. Let's put it there. So I'll click on that, and then we'll go over to this, click there. And you can do a chart output just like you did in Excel. And I think that's it. Then you say OK. And it looks like it's done something. OK. So you can see we have the same result. So what it has done automatically, it's just given us the bin again, or the class. This is from less than 25 or less. This is between 26 and 30. Then we could again manually go and enter these. These can be edited once the thing's generated. And then you have your frequency distribution as well. Okay, so now it said it did a chart output, so I'm not sure where it is, so I might have to zoom out. Let's see. Where did they stick? Oh, here it is. I see it. I see it. So the chart output is over here. And you can see, again, it looks very similar to what we got with Excel. And so just like with Excel, we can edit the graph by choosing the graph, and then it just has a different editing structure. But you can change, you can change the title, you can change we probably go back here and change these in the data table. So anyway, the bottom line is that it's very similar whether you use Excel or whether you use Google Docs. Once you get good at using any spreadsheet, you're going to be able to pick up other spreadsheets fairly easily. So let me switch back over here. Again, I don't expect you to say, oh yeah, I could do that by myself, because it's a lot of information. But again, the purpose is to just get a general idea of what's possible. Let's just look at one more piece of data, just to show you how you can do these. Once you get good at it, you can generate a lot of data fairly quickly. So what I'm going to do now is I'm going to copy these two, and you can highlight the whole row, the whole column. I don't know what happened. How long have I been gone? How long was it since I noticed you were gone? A couple of minutes. Okay. Yeah, I don't know what happened. Okay, to share that. 5 minutes. Okay. Thank you for that. So that's the basic idea behind frequency distributions. Is you're grouping the data into 5 to 12 classes, and then you present the data either as a table or you present the data as a histogram. So we're going to move on. I think I might try to get a computer lab and ask people to actually everybody to come into class one day, and then we can do this a little bit better. It's hard to do this online when I'd like to do an in-class kind of thing. So I'll give you a couple of days warning so that you can plan on actually everybody coming to class, and I need to find a computer lab. Okay, so the next thing is measures of central tendency. This is what you've done before again, so it should be review, and we'll do a few simple examples, and then I will show you how to do it in a spreadsheet format. What's that? Yeah, meeting mode. Range is in the next section, which is measures of dispersion. So. So like I said, I think everybody's had this before, so I'm not going to belabor the point. Try to get something that you haven't done, which is probably use spreadsheets to do this kind of stuff. So the mean, we also call the average, and in most spreadsheets, they use average instead of, well, actually, Excel uses the term average. Google Docs uses the term mean, so you have to look for one or the other. There's this little symbol. This means sum. It means add all the numbers together. So let me just write that down so you know what that means. So, does anybody know what Greek symbol this is? Yeah. What's that? Yeah, I mean, it stands for adds up to. So it's like stands for the sum. But I'm trying to remember. It's sigma, so it's S. Sigma. Yeah, I don't know why I had a hard time, but yeah, it's sigma. That's the capital sigma. The small sigma is what does the small sigma look like? I thought small sigma looks like that. I'm having a brain. I can't remember these days. Anyway, I think yeah. So the mean of n data items is calculated as follows, and we use the bar over top of the variable that so x stands for some value, some set of data. And so the average or the mean, we put a bar over top of it. So the mean is equal to, you add all the numbers together, that's what the summation means, divided by the number of data points. So it's pretty simple. It's just that everybody knows what average is in. So here's some numbers. Let's delete that and just do the simple calculation here just to refresh your memory. So in case of x, this would be x sub 1, x sub 2, x sub 3, x sub 4. There's 7 of them. The number of data points is 7, so you just count how many there are. And so the mean, which is x bar, that's how we say it, x bar, with this something over top. You would take 3 plus 11 plus 7 plus 6 plus 5 plus 4 plus 8, and then you divide by the number of data points, which is 7. So what do we get here? 14, 21, 27, 32, 36, 44. So I get 44 when if you add the numbers in the numerator and you divide by 7. And that's not going to be an integer, so let's see what it is. It's 6.2 9. So that's the mean. So if you have a bigger set of data, you just got to add more numbers together. That's all there is to it. And then divide by a bigger number. So that's mean. That's mean. You're so mean. Now, the weighted mean is when the values in a data set have different weighting factors. And you might say, well, I don't know of any time I've ever done that. Where would that be applicable? And it's actually if you're calculating grades in a class. So in our class, tests are worth 55%, I think, and exams worth 20%, and homework's worth 20%, and attendance is worth 5%. So those are the weighting factors. And so if you have a test average of 70% and an exam of 80, you don't just add those two numbers together. But add that to your homework grade and divide by 4. There are 4 components to your grade, but each one has a different weighting factor. So that's probably the most used example of weighted means. So to do that, you have to know the weighting factor as well as the value for each particular one. So I guess just a normal mean, you'd have a weighting factor of 1 for every part. Each one would have an equal weighting factor. And the weighting factor doesn't have to be, it doesn't have to be a percentage. It just has to be, I could say tests are worth 4 units and exams worth 2 units and homework's worth 2 units. As far as as long as those numbers have the same percentage ratios as the actual percentage that I use. So weighting factors don't need to be decimals. They can be whole numbers. You could say this is worth twice as much, weight, this is twice as much, or whatever it is. So when you do this, just a simple mean, the weighting factors are 1, and so you just add up. When you add up 1 as many times as you have data points, then you get N. So in this case, I've got another set of data. I think it's the same set of data. It's just that I have weighting factors. So we're going to weight this one with a factor of 1, 5 with a factor of 2, 7 with a factor of 1, 4 with a factor of 2, 6 with a factor of 1, and 11 with a factor of 2. So the calculation is very similar. It's just you've got to take your number, your X value, times the corresponding weighting factor, and then you just do that through your entire data set. And I just messed that up. You got to pay attention. So 7 times 1. So I'm taking this times that and adding them together. And I ran the space. I'm just going to keep going here. It's kind of a screwed up fraction, but you should. Okay, then we divide that sum by the sum of products by just adding the weighting factors together. So I think I did that right. And then we're going to use my calculator in this one. 3 plus 10 plus 7 plus 8 plus 6 plus 22. And so I get the numerator to be 56. 3 plus 10, 13, 20, 28, 34, 44, 54. Yeah, okay, that's right. And then in the denominator, I'm adding 3 plus 3 plus 3, which is 9. And so my weighted mean is 9. You might find this interesting. I don't think there's anything that's, well, maybe I can't do it because it might have grades in it. Yeah. Well, I could show you. I don't think I've entered some. In a particular course, I haven't entered anybody's data, so I'm just going to show you how it works when I enter data in for figuring out grades. So let's we'll go to physics, because I know I haven't put anything in there yet. Actually, I'm not sure if I've copied over the formula yet, but we'll see what happens. So in Blackboard, there's something I have called the grade center. And if I go to the grade center like that, what I see is the people's names in my class. So there they are. And what you can do is you can create a calculated column, and there's a weight, so you put in a weighted column, and so you put your column name in, and then what you can do is you can go down here and pick how you want to, what you want to include in your grading. So I don't have journals, but let's say I put a journal in there, and I put a discussion in there, and I put a survey in there. So those are my different, and I'd put in homework, exams, and stuff like that. And so they're different categories, and then I would weight them. I could put in, 25% is the discussion, 50% is the survey, 25% is the journal, and you can, total weight should add up to 100% once I enter that second one. And so what it'll do is automatically weight my grades. So I put in, and what it'll do is it'll take the test averages and it will add those together and give me an average for my tests. So there'll be a test average, and then that will be weighted by the percentage that I determine in my class. So it helps out somewhat. It wouldn't be that big a deal to be doing it manually, but it makes so I have less chance of making mistakes. So that's good. Okay, so that's mean. Now, you can, if you're given a frequency distribution rather than the raw data, you can calculate a mean from a frequency distribution. Now, you probably haven't done this before, I don't think. So this is my frequency distribution that I think I just used, but if it's not, it's close to it. So what this says is from 100 to 105, there were 5. From 100, just above 105 to 110, there were 10 examples. And we really don't know how those are distributed within each within each class. I mean, I could have 5 at 110, 5 values of 110, and none of the other ones. And so that one would, on average, would be 110. But you don't know that, because all you're given is this sort of approximated version of the data. But you have to make some kind of assumption, and what you assume is that every one of these data points, the 10 data points, has the value of the average of the class. And overall, that tends to happen. So you can still get a pretty good mean from a frequency distribution. So again, this doesn't mean that these are all 110. What it means is that from 105 plus to 110, you put them in this class. And if it's from 110 to 110 plus to 115, I guess. So it's just greater than the 110 to 115, then you put them in that class. So to calculate the mean from the frequency distribution, you just take the number of values in a class multiplied by the average value of the class. So since this is from 100 to 105, the average is 102.5. Then you take the number of data points in the next class, which is from 105 to 110, so you'd use the average value for that class, and you continue on with that. So the next class, there are 14 points. We say that they have we assume that they average out to 112.5, and we continue the calculation on. So we have 15 times 117.5 plus 4 times 122.5 plus 1 times 127.5 plus 1 times 132.5. Okay, and then we divide all of that, and you don't add up the number of classes, you add up the total number of data points. So it'd be 5 plus 10 plus 14 plus 15 plus 4 plus 1 plus 1. And let's see, so I'm going to plug this in my calculator. 5 times 102.5 plus 10 times 107.5 plus 14 times 112.5 plus 15 times 117.5 plus 4 times 122.5 plus 1 times 127.5 plus 1 times 132.5. And so you add all those numbers together, and the numerator is 5,675, and then you divide by the sum of the other numbers in the denominator, which are going to be 50, which I thought that's what they were supposed to be. And if you look back at the data, what would be our estimate? Where would we expect the mean to be? I'd probably say somewhere between 115 and 120, maybe, just because that's where the most occurrences have happened. And I can't remember, just a second here. Yeah, it is recording. Just worried I was not recording anything. Okay, so we divide by 50, and we get 113.5. So it's in this grouping right here, a little bit towards the upper end, which kind of makes sense. So that's how you do it with getting a mean from a frequency distribution. The actual average is, I don't know what it is. You know, we could go back. If this is from the data that we used earlier, we probably could calculate the average and see how they compare. You know, what is the accuracy? How much accuracy do you lose by taking the data as a frequency?
Okay, your attendance question for today is, what is the probability of getting hit by lightning? So just put that into your Google search and you'll see it right at the top. And it actually uses that as a comparison to the chances of winning the lottery. So you'll see that getting hit twice by lightning in your lifetime is more likely than winning the lottery. But what I want is the probability, and I guess it's really odds rather than probability. But it's like one out of so many people. What's the probability of getting hit by lightning in your lifetime? And it's between 10,000 and 30,000, just so you know which number you're looking at.
See distribution rather than just the raw data. Okay, so that's the mean. It's just a matter of adding the numbers together and dividing by a number. The median is, to do a median, you rank the items in numerical order from least to greatest, which you've seen me do just a minute ago using the spreadsheet. So, you know, you can use a spreadsheet to help you do that. But actually, the spreadsheet does it automatically. I mean, you don't even have to order it because it will do it automatically for you. So, but if you're doing it, we're going to show you how to do it manually first, and then we'll let the computer do it for us. So there's two cases, depending on whether you have an odd number of data points or an even number of data points. So with an odd number of data points, there is a middle number, so that there are equal numbers to the lower side and the upper side of that value. Whereas if you have an even number, there's no middle number. So what you do is you take the average of the middle two numbers, and that's it. It's just a ranking. So where, you know, why, does anybody remember under what circumstances a median is a better number to use versus mean? It seems, yeah, right. So if you have a couple of outliers, they're not going to throw off your median that much, but they could throw off your median a lot. I mean, you mean awful lot. So outliers just mean, like when I was looking through that data and I threw out 0% body fat, I knew that was wrong. That would have thrown off the mean somewhat, not a whole lot because there was so many data points. So the more data points you have, if you have one outlier, it's not going to hurt you that much. But if you have 5 data points, one outlier can cause a problem. And sometimes outliers are real, and sometimes they're just bad data. And you can usually, a lot of times you can figure that out. It's not like you're not massaging the data. You know, sometimes people say you take data and you pick the data to get your conclusion. That's bad. But if you look at your data and there are obviously things that somebody typed in a number wrong or did something obvious, it's not, you know, it's not unethical to take out that data. You know, you can use a little bit of common sense and reasoning in cleaning up your data set. Now the mode is when you list the numbers numerically, it's easy to see which data points are listed the most. And this usually, a mode is usually important where you have integers and you don't have very big integers. So age, like that, we were looking at age earlier, they're probably, you could probably use mode there as a reasonable thing. But if you were talking about weights where you have just decimals, there's just a mode a lot of times doesn't make a whole lot of sense. Mode is used much less frequently than mean and median. Those are the 2 important ones. We'll show you how to do it, but the reality is that it's not used that much. Okay, so here's a bunch of data to calculate the mean, the median, and to do a histogram of the data. So the question is, how are we going to do this? I think I have a, let me just move one step ahead here, one page ahead. Okay, that's not, yeah, that's my, using stem and leaf plots. Yeah, to order something like this with so many data decimals, it's a little more difficult just because you have to think a little harder about that. So what kind of strategy would you do if you wanted to manually order these numbers? And you almost have to kind of like do it in multiple steps, where what I would do, so let's think about strategies here if I were doing it. And in this case, the stem and leaf plot might be somewhat useful, but what I would do is I'd look through this to find kind of the values, the minimum value and the maximum value. So I look through here and I see a 70, I see a 68, that looks like a 45, yeah, there's a small one, okay. Yeah, they would. It's really hard to see that, isn't it? Let me put it on one page so you can see a little, whoops. Yeah, I'm not sure why they don't put commas, but you're right about that. So even just, yeah, trying to make sure you look between the dates. So it looks like 45 is the smallest number, and there's a 383 here. So what I would do probably is I would break it up into maybe subgroups here, so I can have some organized way of doing it, maybe in hundreds. So what I would do is I'd draw these lines and I'd say, you know, from 0 to 100 put here, from 100 to 200 put there, and so I'm going to do a preliminary sorting, and then I'll do a more complete sorting once I get going here. So I'm really rewriting these to some extent, and what you can do is you can kind of, you know, the numbers that are in the middle, I'm going to put in the middle, okay? So 383 would be maybe like this. 90, I'm going to put about here, 90.9, 178.1, 267.5, 95.5, 156.5, 180.0, 90.9, so I'll put another one there, there's 90.9, 139.7, 200.2, 171.7, 187.9, 187.2, 184.9, running out of space here, 70, put that there, 70.1, 58.0, 84.1, 56, 55.6. And so you can see what I'm doing is I'm trying to get some initial semblance, because ultimately you want a list of numbers in a vertical row or some way to do that. And the question is, how do you make sure you have enough space to include all these? And you could just make a big piece of paper and you could start writing them down and then ordering them around. So it's doable, but I'm lazy. So what I'm going to do here is I'm going to figure out some way of using my spreadsheet. Actually, what I'm going to do is this little trick here. If I just paste that into Excel, it's not going to work too well. So what I'm going to do is there is a thing called Notepad, and I'm going to paste that into Notepad. And it looked like to put a little extra. I didn't want to do that. Where do you have to undo? Okay. Just make sure. I thought I saw. No, I think it was just. It looks like there was a weird character. Okay. So then what I do is I'm going to save as some file name. So I'm going to call this test.txt. Okay. So do that. And then what I can do is I can go into, this is one thing you can do in Excel, which is is pretty neat, is you can read in data. So it says data from text, and if I can remember where I saved that file, so that was, well, let me go back because I can't remember where I saved it. Let's see. Save as. So it's in chapter 12. Okay, so that's where it is. So if I go back to Excel and go to chapter 12, there it is. There's my text file. And so it'll give you a way of doing this, and I'm going to. There's different ways of delimiting files. A delimiter is just a way of separating data, like commas. So you can use tabs, semicolons, commas, space, or other. So it looks like space is going to be the best way of doing it. So rather than me having to enter all that stuff, so I'm going to pick space. And notice it's what we would say parsed or separated the data. And then I'd say finish. And I'm going to put it right there. And it's horizontal, which is not exactly the way I want it. So you can actually take the data and then it's called transpose. What that does is it when I paste it, if I transpose it, it will make everything into a column. Okay, so now I have everything into a column. And then finally, what I could do is I can take that data. Instead of me having to do this manually, you would sort it, and there we go. Now it's sorted. So that was a lot easier, wasn't it? It took a few extra steps, but it's obviously we could do it manually, and it would take a long time. But now we have the data sorted. That's the important thing. If I give you a test problem and you have to do mean, it'll probably be 6 or 7 numbers. Okay, so this is a larger number set. So if you have 6 or 7 numbers, it's going to be obvious, very easy to sort the data numerically. So the key thing is, so we've done the first step, and I don't think I shared that part with the group here. So I did all that without showing it, but it doesn't matter because I was just demonstrating how to do the whole thing. So the question is, how many numbers do I have? Because once I've sorted them, you have to figure out whether it's an odd or even number. So there's another instead of me having to count that, and I could count them easily enough, but there's a command called count, and what that does is it doesn't add the numbers together; it just counts how many cells there are, and it'll say it's 47. So there's 47 data points. So if I go back to the instructions, it said if I have 47, if I have an odd number, it's going to be the middle number. And so usually when I do these, I create a column that has the numbers. I just number them in sequential order. So this is my 47th number. So the middle number, what you would do is you take 47 and divide by 2, which is 23.5, and it would be the 24th number. Okay, so I go up here to the 24th number, and that would be the median. Except that's not spelled right. Median. So 24 is the median. Oh, 24th number is the median. The median value is 133.1. And that's because there are 23 numbers less than the median, and there are 23 numbers greater than the median, and that's 46 numbers, and then there's one number that is the median, and so that's 47 numbers. So that's the way you go about doing medians. The hardest part is actually ordering the numbers. Thank goodness, you'll either have a small number to do. If I do it on a test, maybe at the exam, I might put a median, which I think I did last year. I'll do a simple median calculation, or you'll do it as an Excel project, and you'll be able to have the Excel or Google Docs do the sorting for you. We don't want to make math mundane. We'd like to make it so that the mundane parts are done by the computer. So let's just compare. That's the median. Let's calculate the mean and see how the median and the mean compare. So in this case, I'm using, this is Excel, so I need to use average. Keep forgetting. Doesn't like that. So let's change that to average. I think so, yeah. Yeah, I don't know. It's shorter. And it has the same letters, mean, median, and mode, so you get the same, I don't know. I don't know what the history about that is. So the mean is 137, or the average is 137. The median is 133. So they're usually pretty close to each other if it's distributed according. Yeah, and you get the same number. And actually, in the project, I have you do it that way and using the built-in function to show you get the same number. So yes. So let me just show you. So if you wanted to just use the definition of mean, you would add all those numbers together, which uses the sum function in Excel, and you would divide by, what happened here? You divide by 47, and you'll get exactly the same number. So it's not that hard to do the mean calculation, but it's even easier just to type in this case, average. Okay, so we'll continue on next. I'm going to go ahead and assign the homework here. So let me just, there it is. So that's a homework assignment for a week from now. So sorry about doing that at the last minute there, but so most of it is just simple adding stuff together, dividing by the, just simple mean calculations. You might have to order some things together, do it manually. Let me just stop the recording here before I forget.